All right. Second video, elements, compounds, and mixtures. We're going to dive deeper than you have in previous classes or in previous videos. If you guys took elements, compounds, and mixtures video and notes in the science review, still the same objective here, distinguish between elements, compounds, and mixtures. Again, we're going to dive a bit deeper with this in this unit though. Page 21 is where these notes are going to go. So flip to page 21 if you're not already there, and we're going to go ahead and get into elements, compounds, and mixtures. So some definitions, looking at elements versus compounds, what do you think the difference between elements and compounds are? Think about what the difference between those. Pause and see if you can come up with what the difference in the definitions are going to be. All right, welcome back. So if you are going to go ahead and pause the video again, think of something that is an element. Think if you can come up with something that is an element. All right, so you have kind of made predictions on the differences here. So elements are going to be substances that can't be separated into simpler substances by a chemical change. That is kind of the key here, looking at a chemical change. No chemical change can get an element into simpler substances. Instead, it is a pure substance made of only one kind of atom. So if you are looking at an element, it's the simplest form of matter that has unique set of chemical properties. So it is going to be the building blocks for all other matter. Some examples, thinking about things like iron. Iron, if you look at on the periodic table, is Fe. If I have a block of iron, then the only atom that is making that up is iron. If you look instead at like helium, so in a helium balloon, if it is pure helium, then the only element, the only kind of atom in that balloon is helium. The only kind of atom is helium. So those are some examples of elements. Compounds have two or more elements chemically combined, and here's the key for compounds: in a fixed proportion. Okay, it's got to be a fixed proportion for a chemical compound. And the other piece is it has to be a chemical combination. So with that, if you're thinking about something to be a compound or not, two or more elements chemically combined, what about N2? What about N bonded with another N? So if we've got nitrogen bonded with another nitrogen, what do you think? Is that a compound or no? It is not, because I've got only nitrogen atoms. I've got only nitrogen atoms. That would actually go back in that element category, element classification. Instead, if you've got something like sodium chloride, you've got Na, sodium atoms, chemically combined with chlorine atoms, Cl. So notice whenever we write that as a formula, that's going to be NaCl put right next to each other, no space between them. If you saw something like Na plus Cl, that would show that they are separate and distinct, so that would not be a compound. But if you put them right next to each other, then that's going to be a compound. Magnesium oxide, again, put right next to each other, that's going to be a compound. Sodium chloride, CaCl2. CO and CO2 are both different compounds, and here's where that fixed proportion comes into play. So my one compound here, CO, has a fixed ratio of 1 to 1, so that's one compound, whereas my CO2 has a 1 to 2 fixed ratio, so it is a different compound. And then some plant sugar, you'd have a fixed ratio of 6 carbons to 12 hydrogens to 6 oxygens, so that would be my fixed proportion for plant sugar, my fixed ratio. And then refined sugar, sucrose, you'd have a 12 carbon to 22 hydrogen to 11 oxygen. Elements versus compounds. Compounds can be broken down into simpler substances, namely their elements or other smaller compounds, by chemical means. Elements, you cannot. They are already in their simplest form. So pure substances, elements and compounds are both pure substances, and every sample of a given pure substance has identical intensive properties. Intensive properties are exactly the same because they have the same composition. So since they've got the same composition, their intensive properties are the same. So quick check. Think, what did we say intensive properties were? So intensive properties were the ones that depend only on the substance. So depend only on the substance. And it does not matter anything to do with the amount. So if you have a pure substance, all of those intensive properties are going to be identical because of the same composition. Properties of compounds. If you were looking at a compound, it is going to have very different properties from the elements that make it up. In general, very different properties. So if you're looking at sodium and chlorine, when they chemically combine to form sodium chloride, their composition changes, and that changes the property. So if you are looking at sodium, and if you're looking at chlorine, you're looking at salt, think of some properties that you might know about each of those. So sodium is a metal. It is a soft metal, and it is incredibly reactive with water, dangerously reactive with water. It'll explode if you put it with water. Chlorine is a incredibly poisonous gas. It has that yellow hue. You can see it in this flask here. And when you combine them together, you get table salt, something that we eat all the time. So those properties drastically change. You can put salt in water, and it's perfectly safe. So when you get a compound, again, those properties change drastically from the elements that made them up. So pure substance, you've got element or compound. Mixture, what do you think? It is going to be a blend of two or more pure substances. So if you've got multiple pure substances, then you're going to be looking at a mixture. Think of some examples here. Let's dive into it. So we've got pure substances and mixtures can be distinguished how? If you've got a composition of a material fixed, it's going to be the same every time. That's going to be a pure substance. If you've got something that varies or can change its composition, then the material is a mixture. So let me break that down for us. So if I'm looking at a pure substance, the composition is fixed. So that's something like a block of iron. It's made up of only iron atoms. So the composition is exactly the same no matter what. So that's a pure substance. In contrast, if I've got something like sugar water, if I've got sugar water in here, then I could put 1 tablespoon of sugar in 1 cup of water, stir it up, but I could put 2 tablespoons of sugar and stir it up. Would those have the same composition? No. Their composition would vary. It could change. So that means that sugar water is a type of a mixture. So what are some other examples of mixtures that you can think of? So yeah, you probably came up with things like Toy Box, some most foods that we eat are types of mixtures. Most drinks that we consume are types of mixtures. Backpacks, toy boxes, lots and lots of things are mixtures. So thinking about that, would you drink salt water? Well, if you've got Gatorade, if you're looking, has sodium chloride dissolved in it. So oftentimes we don't think about it that way, but in reality, we do drink salt water pretty regularly. So we are constantly, like I said, most of the drinks that we drink are some form of a mixture, and we can break those down into two different categories: heterogeneous mixtures and homogeneous mixtures. First, I want you to pause the video and think, what do you think the difference between heterogeneous mixtures are and homogeneous mixtures are? What do you think the difference between those two are? Okay. Can you think of any examples of either of those? All right. So heterogeneous mixtures are mixtures with visibly different parts. You can see the differences between them. So things like granite or gravel, chocolate chip cookies, things that obviously you can see as you're looking at them, the different parts. Okay. Homogeneous mixtures, they do not show those visible differences for their parts. So things like sugar water, if you've stirred that up completely, eventually that sugar is going to dissolve. The seawater, assuming that you get a part that is clean, you're going to be able to see completely through that. You're going to think that looks like a single substance. Air is made up of a lot of different elements and compounds, and all of those are mixed together. You can't tell the difference between those. Gold rings are also mixtures because they are actually called alloys. You take gold, it's too soft on its own, so you mix other things like zinc and other metals in to make it a little bit stronger. So those gold rings are also homogeneous mixtures. Homogeneous mixtures also are called solutions or aqueous solutions. I'll spell that for you. So aqueous, A-Q-U-E-S-O-U-S, aqueous solutions are homogeneous mixtures. So separating mixtures, one of the most common ways for heterogeneous mixtures is filtration. So you can get filter paper or some sort of a screen like you see in this picture here to be able to filter out the pieces. Because there are obviously different parts, you can sift through those, you can filter them. You also see that in things like a coffee filter or a colander to be able to filter out your pasta noodles from the water. So anytime you have a heterogeneous mixture, filtration is a really solid way to do that. If you are looking at homogeneous mixtures, though, distillation is one of the most common ones if they have different boiling points. So if you have two substances that are in the liquid phase and they have different enough boiling points, then you can take them and try to convert them from liquid to gas, get them to boil up here, and then condense them back down so that the one that has the lower boiling point ends up more pure over on the other side. So that is distillation. This is how we refine petroleum in for gasoline. Then another form for homogeneous mixtures is going to be crystallization. This is delicious rock candy is made by crystallization. You dissolve a lot of sugar in water and then you let the water evaporate away with one of these sticks inside of the water, and the sugar will crystallize onto that stick. This process is also how gemstones like amethyst and things like that are formed. Then last one is for also homogeneous mixtures, chromatography. So you see if you've got a substance down at the bottom and a liquid, a solution will try to pull up the different substances, and if you can get the right ratio, then you can separate those different pieces. So this works really well with ink or chlorophyll from plants. Also, you can use chromatography to do that. So to classify items, you can break those down into either a pure substance or a mixture. If it's a pure substance, it'll either be an element or a compound. If it's a mixture, it'll either be a heterogeneous or a homogeneous mixture. So for each of these 5 substances, I want you to think about, is that going to be a pure substance or a mixture? And then if it's a pure substance, element, or compound, if it's a mixture, is it heterogeneous or homogeneous? Pause the video, tackle each of those 5. All right, welcome back. So sodium bicarbonate. Sodium bicarbonate is NaHCO3. That is multiple elements chemically combined together. So that is going to be a pure substance because it has the same composition no matter what, a definite and fixed proportion, and then it is going to be a compound because it's got all of those elements chemically bonded together. Stainless steel is iron mixed with carbon, so that's going to be a mixture. And if you look at stainless steel, you can't see the different pieces of iron and carbon, so that's going to be a homogeneous mixture. Nail polish. Nail polish, if you were to go and look at the ingredients on your nail polish, it depends a little bit on what nail polish you've got. So if you've got one that is just acetone, acetone is a compound, but if you had one that listed off multiple different compounds, then that would definitely be a mixture. So it just kind of depends a little bit on which one you've got. And then blueberry bagel, this one should be pretty obvious to you as a mixture because we've got the blueberries and the different ingredients that make up that bagel, and you could see the blueberries versus the bagel, so that's going to be heterogeneous because you can see the different parts. And then uranium. Uranium is an element on the periodic table, only one type of atom, so that is a pure substance and an element. If you had any questions on any of those, make note of that and be able to ask me in class. Again, I want to be able to support you guys as you guys are trying to work through that. So summary, you need to know elements and compounds, be able to distinguish between those and give the differences and similarities. Mixtures, need to know heterogeneous versus homogeneous, be able to classify the different types of matter and analyze how to separate mixtures. So did you take notes? Anything you need to revise as you've gone back through that, or any questions you need to make note of? Again, bring all of those to me to class, and go ahead and you can try to start on the practice. Again, thank you guys for being awesome, and let me know what questions you've got and what I can do to help. Thank you guys.